So for this particular question, the first part is to show that the derivative is equal to this. So we're going to look at what this is. I can see that it would be easy to take the derivative if I'd use the power rule term by term. So I get 3x squared minus 6x minus 9. I need to show that it looks like this. So my first thing will be to use the answer as a clue. And it says here that there's a factor of 3. I can see there's a factor of 3, so I'll take that out first. So I get 3 outside of x squared minus 2x minus 3. Now I'm looking at this, it's a quadratic. Looking at these two, I can see that yes, that is indeed a feasible factorisation. I'm going to have an x and an x, two numbers that multiply together to give me negative 3, be minus 3 and plus 1, because then when I add them, I'll get minus 2. So that is as shown. Then I need to sketch the derivative. So what I'm doing is I'm going to sketch this quadratic now. I need to show when it's increasing. So to sketch the quadratic, I'm going to use the factored form here, because this tells me the roots are at minus 1 when this p is equals to 0, and at x equals to 3, where that piece is equal to 0. It's a positive quadratic, so I'm going to have this shape. When x is 0, I'm crossing down here at minus 9. And I know that the quadratic is symmetrical, so I know that at 1 here, which is halfway, is where it's going to turn around. So what I'm going to do is I'm going to sketch that in. Comes down through there, turns around, and then goes up that way. Oops, sorry about the bump. And then I need to look at this particular function. So here the derivative is positive above 0 and it's negative below 0. So I can see here that it's increasing, which means positive, when x is greater than positive 3, or when x is less than minus 1. That's where it's positive. So that is where the function then would be increasing. It'll be decreasing because the gradient is negative between those two values.